Dear students, I welcome you all for listening this lecture video. So this is the second problem on kinematics of rigid bodies. So this is the problem. So here a motor starts from rest. So it is given as the initial condition of the motor is at rest condition. So at time t equal to 0, the initial velocity of the motor u can be taken as 0 meter per second and uniformly accelerated to a speed of 20 km per hour. So at the second condition, final velocity v can be taken as 20 km per hour over a distance of 200 meters. So this is S. The distance traveled to attain the final velocity of 20 km per hour is 200 meters. So for this condition, calculate the acceleration and time taken. Then in the second portion of the problem, it is mentioned that if further acceleration raises the speed to 50 km per hour from 20 km per hour. So in this condition, the speed of the motor is given as 50 km per hour in 8 seconds. Find the acceleration and the further distance moved. So here in this problem, two distinct conditions are given. So in the first condition, the initial velocity u is 0 and the final velocity v can be taken as 20 km per hour. And in the second condition, the initial condition of the motor is not at the rest position. It is moving with the initial velocity of 20 km per hour. So for the second condition, u can be taken as 20 km per hour and v can be taken as 50 km per hour. So there are two distinct conditions. Okay. So with this formulation, we can proceed to solve the problem. So there are three relationship equation we know for solving the problem on kinematics of particles. V is equal to u plus at, s is equal to ut plus of at square, and v square is equal to u square plus 2as. So for the given problem, first to find out the acceleration value, we can go with this formula, third formula, that is v square is equal to u square plus 2as. So we can substitute all the known values in this equation. We can take this as equation 1. So for the first condition, the final velocity v is known to be 20 km per hour. So for converting this value to the SI unit for the final velocity, that is to convert kmph to meter per second, we have to multiply this value by 10 power 3 and divide by 3600 seconds. So V value will be with the unit of meter per second 5.555 meter per second. So 5.555 square, and the initial velocity for the first condition is mentioned as 0 plus 2 into acceleration a into the distance travelled at this condition is 200 meter. So by resolving this equation, we can get the value for acceleration a as 0.077 meter by second square. Okay. So for the first condition, we are asked to find out the value for acceleration and time taken. Okay. So now in this equation, we know the value for v, u, and also the value for acceleration. So now we can use this formula to find out the value for time taken to travel the mentioned distance of 200 meter with an accelerated value of 0.077 meter per second square. Okay, so now to calculate the value of time taken, we can use this formula. So name this as equation 2. By applying all the known values in this equation, we can get the value for the time taken. So V value is known to be 5.555 is equal to initial velocity is 0 plus acceleration value is 0.077 into t. So by resolving this equation, we can get the value for time taken t as 72.14 seconds. Okay. So these are the answers for the first questions, first subdivision. Acceleration value is 0.077 meter per second square and the time taken t is 72.14 seconds. Now coming to the second portion of the problem. Now in the second condition, the motor is initially traveling with the velocity u is equal to 5.555 meter by second and the final velocity v for the second condition is mentioned as 50 kmph. So converting this into meter per second, 50 into 10 power 3 meter divided by 3600 seconds, this will be 13.89 meter by second. Okay, so the initial velocity and final velocity values are known. So this distance is traveled within the time period of 8 seconds. Okay, so for this available data, we are asked to find out the acceleration value and the further distance moved. Okay, so now we can use this formula v is equal to u plus at because here we know the value for initial velocity, final velocity and time period. So in this equation now the one and only unknown variable is acceleration. So for the second condition of the problem, directly we can use the formula v is equal to u plus at. So here for the second condition, v value is known to be 13.89. U value for the second condition is known to be 5.555 plus A into time period is 8 seconds. So by resolving this equation, we can get the value for acceleration A as 1.0418 meter by second square. Okay, so to increase the speed from 5.555 meter per second to 13.89 meter by second in the time period of 8 seconds by accelerating with 1.0418 meter by second square, how much distance can be traveled by the given motor? We can calculate that value by the equation s is equal to ut plus of at square. Okay, so the distance s can be calculated with this formula. Here u is 5.555 into time period is 8 seconds plus of into acceleration value 1.0418 into time periods second square. So by resolving this, we can get the value for the distance traveled for the second condition as 77.78 meter. Okay, this is all about the problem.